Hello guys, welcome back to Codemi. My name is Shri Bhagwat and today we are going to start with our second video in our Dart and DSA course. Our today's topic will be Introduction to Programming Language. So before moving on with data structures and algorithm, let us first learn and understand what a programming language is. Okay? So in this video, we will be exploring about programming languages, types of programming languages, how are they classified, and what a programming language mean. Okay? So without waiting ado, let's get started. Before moving on, please like, share, subscribe this channel, share this video, like this video. Okay? This is going to be a huge course. And programming language. So before understanding about Dart and data structures, let us first understand what a programming language is. Now let's say you want to communicate with a person. So you must understand what language that person speaks so you can communicate with that person in that language. So to communicate with a computer, you must understand what language a computer speaks. Okay? Now, a programming language is a language used to communicate with a computer. So when a human communicates with a computer, he needs to communicate that with a programming language. So before understanding what a programming language is, we must first understand how a computer communicates, in which language he communicates, or what is the mode or the medium in which a computer communicates. So we all know that a computer communicates in binary language, that is 1 and 0. So everything that we see or everything that a computer interacts with, it first has to convert that in 1 and 0. Okay? That is called as compilation. So a computer compiles whatever it sees on the screen or whatever it has to process or whatever interaction we do with the computer into 1 and 0. And it is called as binary. Why? Because there are only two digits, 1 and 0. So a combination of this 1 and 0 together creates alphabets, letters, numbers that we human can understand, and vice versa. And the alphabet, letters or numbers that we input inside the computer gets converted into this binary code which a computer understands. Now, a digit or a bit is the smallest unit of data in computing, and binary numbers are made up of binary digits. As you can see on the screen, I have displayed a few examples of how binary digit is. You can see A is an 8-bit binary number, is 0, 1, 0, 0, 0, 0, 0, 1. So wherever there is A, the computer will convert that A into the binary number that represents A. And that is how a computer comes to know that this binary number means A. And this is how the computer compiles. Okay? So how this process works is as follows. There are input devices. For example, keyboard, mouse, or whatever instructions we are giving to the computer, they all are given by the set of input devices. Okay? When we give the instructions, then the processor, it converts our sets of instructions into binary code, does the tasks assigned to the computer, and then again converts the binary code into a human readable language and shows that on the output devices. Now what are output devices? It can be a printer or a screen or speakers. Let's say you are getting audio from a computer. That is how it works. Okay? So first the data is given to the computer, the tasks, the computer converts a human readable format into a machine code which the computer can understand, processes the task that the human have mentioned, and then again converts the machine code into a human readable format and it displays that data onto the screen or onto the output devices. Now coming back to our programming languages. So now to communicate with the computer, we have to understand a language which is understood by both a computer as well as humans. This is where a programming language comes into our rescue. We type in a human readable programming language which is compiled to the machine code, and then the computer understands what we are saying or what we are giving instructions or what kind of instructions are given to a computer. Now there are many different types of programming languages, but we are going to see what are the main three types of programming languages. So programming languages are categorized as procedural languages, functional languages, and object-oriented languages. Now what are procedural languages or procedural programming languages? So it follows a procedure. You can see in the name, it follows a procedure. It is a well-structured step-by-step guide or a step-by-step programming language. It contains a systematic order of statement. For example, there is a statement 1. After that statement 1 is done, it will move to the statement 2, then to the statement 3, or let's say instruction 1, then instruction 2, and then instruction 3. So this will be a step-by-step procedure and the steps cannot be skipped. For example, in our day-to-day life also, there are many procedural work that we have to do, and we know that we cannot skip that procedural work. When I am working on a task and the task requires something beforehand, I have to make sure that I do the required task before. Let's say you want to add two numbers. You cannot have a flow as in take number 1, add the two numbers, and then take number 2. The procedure should be take number 1, take number 2, add these two numbers, and then display the answer. So this is a procedural step-by-step way how we can do this task. The same concept is followed in procedural programming language. Then comes functional programming language. So in functional programming language, everything is done in pure functions. You can only create variable, you cannot modify them. So whenever a function is run, new variables are generated. When you run that function again, even more variables are generated. And in functional programming language, importance is given to the functional part. Now what is a function? In our future videos, we will be exploring more about function, but to understand, a function is a block of code which is set aside, and just calling by that function, we can call that function, or we can tell the computer to do the predefined task. Let me rephrase again. A function is a block of code, predefined code, which when called will do all the tasks in that function. Now one example for this is, let's say every day in the morning I get up, I brush my teeth, I take a bath, and then I go to buy some milk and some bread. So this is the task that I do every day. And now I want to lay this task to my let's say maid or a worker who is working at my place, or to someone. So every day in the morning, I can tell each and every task single-handedly. For example, get up, brush your teeth, then take a bath, then go to the shop and get some milk and some bread. But instead of telling all the tasks or all the instructions separately, I can just create a group of tasks and I can name them as morning tasks or morning routine, which will have subtasks inside them, as getting up, brushing your teeth, or going to the shop and getting milk and bread. And I will just tell him to do the morning task, and he will know what all task he has to do. Means everything that comes under the morning tasks, he has to do it. Same goes with the functional programming. there are a set of tasks which we will set aside, and we will make a block of it, and we will just call that block of code which will tell the computer to run the task present in that block. So let's say there is a repetitive task that I have to do is to get the data from the internet and store that data into the local database. So instead of writing that each and every task again and again, I can just create a normal function which will denote or explain all the steps to the computer, and then I will just call that block of code again and again whenever I will need it, which will save my time and will help me to program better. So this is what a functional programming language is. It revolves around functions. Now coming back to object-oriented programming language. Now object-oriented programming language is the most widely used programming language. Why? Because in this language there is an object. As the name suggests, it is object-oriented. So the object is given the most importance. Now what is an object? Object is an instance of a class. So before going to object, let us first understand what is a class. Now let's say there is a mobile phone, and mobile phone has different properties. For example, its color, its specification, the RAM it has, the hard disk or the storage it has, then the screen size, the camera megapixel it has. Now instead of creating a separate data type for all these small values, I will create a big data type called as a mobile, and then inside that big mobile data type, I will mention this small values that I will be needing. So when I will create a new mobile, all I have to do is just take a data type of this mobile. So over here, the mobile becomes the class, and the mobile which I am creating from this big data type becomes an object. This is how object-oriented programming works. It is code plus data. The code that we will be writing, and with that, the data that we will be submitting. The second example, let's see. I have to get data of all the students in class 9. So now a student is having name, a student is having his roll number, his division, his standard, and the fees that he has paid, the subjects he has chosen. And creating a data type for each small value is very tedious job. So what I will do is I will create a big database called as students, and that will be called as my class, and I will define these properties inside that class student. And when I will create an instance of that class, that will be my object. Okay, I hope this is clear. In our future videos, we will be exploring more about object-oriented programming and what is an object, how you can create classes and all. But for now, class and object, these two are major factor. Object-oriented programming language is widely used because it reduces the development work and it gives a clear picture for the developer what he has to develop. Now, there is another type of classification. The first classification that we saw, it was based on the architecture of the language. Now, the classification that we are going to see, that is based on how the language is typed or how it runs actually. Now, there are two types. One is a static type and another is dynamic type. In the name, we know that static means which does not change, and dynamic means some things which can change. Okay, so the first point you will see in static is type checking at compile time. Before we move on, let us first understand what is type checking or what are types. Now, we will explore those topics in our next or in our future videos, but just to understand, every property that we have or every value that we hold has some type. Example, if we are having a number, it is a type int, or we can call it integer. If we are having letters or alphabet, then the type is string. Okay. If we are having just true and false kind of a data, then it is called as a Boolean. So these are called as data types. So, and what is compile time? As I have mentioned before, our processor compiles our human readable language into our computer machine code language. Now this conversion of our human readable language to the machine code language is called as compilation. Okay, so whenever we type a code and we hit the run button, the first step that happens is our code is compiled to the machine code. And at that time, a check is happening. What it checks is the data type. Are they matching properly? If the data type is matching properly, then only it moves ahead to create that application. So this is done when we use a static language. The type check is done at compile time. And if the data type is not matching, let's say I have taken an integer and I have declared a value as or defined a value as Shri to that integer, then there is a mismatch in the data type. And hence our program will fail at the compile time. Okay, and it will throw an error or show us an error. So in static language, we get an error at the compile time when it fails to compile the language. You have to declare the data type before you use it. This means that I just cannot create a variable without telling what data type it needs to be. I have to mention my data type. So I have to always start with string name is equal to Shri. When I do that, I tell the language that okay, this is a string data type. The variable name is name and the value it holds is Shri. This is a static typed language. You cannot interchange the data type. For example, if the value is, let's say I've taken a variable A and assigned a value 10, I cannot reassign Shri to the variable A. It will again throw an error. Okay. So a static type language is, we have to work a bit more. We have to write extra code, but then the chances of failure are very less. Now coming next to the dynamic typed language, there is no checking at the compile time. The checking there is at the runtime. Now what is runtime? When the application runs, that is called as a runtime. So what happens is when we create a variable and we assign a value to that variable, it doesn't check if the value and the data type is matching. Now for that, we don't have to declare the data type when we define a variable. We can just write A is equal to 10. And in the next line, I can also write A is equal to Shri. At the time of compile, the application will get compiled and it will run. Why? Because it has chosen the next value that we have defined. The major drawback of dynamic language is that while the application is running, if we get some data and the data type of that data is changing, then the value will change and our application might fail or crash. Okay. The error is shown when the program is running. So the debugging is also very hard and the error might occur even in the production part of the code. Best example of our dynamic data type language or a dynamic typed language is JavaScript. If you'll ask me what I choose between a static and dynamic type language, I will always say that I personally choose a static type language. We have to work a bit, but once the code is done, it is error proof, at least from our syntax point of view. There might be bugs, but from a syntax point of view, it is error proof. After understanding a dynamic type and static type, in the next video, we are going to understand what are variables, how to create variables, what are operators, the arithmetic operators, logical operators, relational operators, and loops, conditions, if else, switch case, for loop. Okay. And after that, we will go into installing Dart and doing a deep dive into our Dart language. So please like, share and subscribe this video. Share with your friends. This is going to be a long course and this will really improve your knowledge in DSA as well as in Dart language. So bye bye. Take care.